In this example, we're going to go ahead and try to solve this polynomial equation, find any real or imaginary solutions that it may have. These solutions we will call the roots of the equation. The first thing we're going to want to do is go ahead and get this equation equal to 0. We can do that in one step by just subtracting this 3x term over to the other side. I'll go ahead and do that now to get 2x to the third minus 5x squared minus 3x is equal to 0. At this point, we really want to try to factor this. We can get it broken down into its factors. We can take advantage of the zero product property, where we can just set each of those factors equal to 0. If those factors are all linear, we can set them equal to 0 and solve them pretty quickly using inverse operations. If the factors happen to be quadratic, then we can always revert back to the quadratic formula if we don't know how to factor that or if it's not factorable any further. That. So looking at the three terms, 2x to the third minus 5x squared minus 3x, the coefficients don't have any common factors other than 1, and that won't really help. So we're really just focusing in on the variables here. X to the third, x to the second, and x to the first all do have a common factor. They all do share a power of x to the first for that. So we can go ahead and factor an x to the first out of each of these terms. I'll do that now. That would leave me with 2x squared. Each power of x is just going to decrease by 1 as I factor out this common factor. Minus 5x minus 3 is equal to 0. Now, this first factor being linear, I could go ahead and set it equal to 0 and have one of my solutions very quickly. This second factor being quadratic, if I wanted to, I could use the quadratic formula to solve this by setting this quadratic trinomial equal to 0, using a as 2, b as negative 5, and c as negative 3. I'm not going to choose to do it that way myself. I prefer factoring when possible, and this is factorable. Test your number sense, though. So I said if you spend more than a few minutes trying to factor this and you're unsuccessful, you might want to just revert back to using the quadratic formula. Maybe you're struggling because it's not factorable, or maybe you're just not seeing the right combination of numbers. So I'm going to go ahead and continue factoring this. Leave this x alone for a second. And I know that this quadratic trinomial right here is going to break down into two binomials. The good news for me, the coefficient here is prime. So I know that if I split this apart as 2x and 1x, I've done that correctly. I don't have a bunch of different options on how I can separate that. And same thing here with this negative 3. 3 being a prime number, its only factors are 1 and 3. I just need to make sure I get the right one positive and the right one negative and get those numbers in the right place. It just requires a little bit of number sense and kind of trial and error with that. I can pretty quickly see that if I put negative 3 here and positive 1 there, 2x times negative 3 would make negative 6x. 1 times x would make 1x. And then those two terms together, the negative 6x and the positive 1x, would make the negative 5x that I needed in the middle. So I know that I have this factored. Now that I have it factored, I'll take advantage of the zero product property, and I'll set each of these three linear factors equal to 0. So we'll have x equals 0 from the first factor. That's done. I already have a solution from that. I have 2x plus 1 equals 0. Two steps of algebra, I can have that solved for x. First, I'll subtract 1 on each side, and that will get me to 2x equals negative 1. And then I will divide by 2, and that will get me to x equals negative 1/2. And I apologize for writing a little small there at the bottom of the board, but it's a small board and I'm running out of room. And finally, the last factor, set the x minus 3 equal to 0. In one step of algebra, adding 3 to both sides, I can get that x is equal to 3. And I have found all three solutions to this polynomial equation. In this case, they all happen to be real solutions. Go ahead and try this one on your own. I will post the solution as well so that you can take a look and see how you did and kind of evaluate where you are with this. So we'll call it the you-do problem. And let's try 4x cubed is equal to 4x squared plus 3x. So take a look at that one. Remember, get everything equal to 0 first. I might recommend moving these two terms over there. And then factor out a greatest common factor if you can. continue to factor what's left, or if you can't see how to factor what's left, try to use the quadratic formula to finish it off. Then you can check how you did here shortly.